All right, welcome back, everybody. Let's start off the day with some review over yesterday's challenge. So it looks like the first thing we have is write a method that takes in an uppercase letter of the alphabet as a string and returns the integer corresponding to its place in the alphabet. So that seems like a pretty complex exercise, but I think I can import ASCII. Let me check this one. ASCII in Python. I think that's what I'm looking for. Board is what you used. Let me see. Finding corresponding place of letter in alphabet in Python. And the only reason why I'm doing this is because I know there's a way easier way to do this. Here it is. So I got an import string. And then after that, I can use ASCII dot underscore lowercase or uppercase to be able to grab a letter. So let's see what we can do here. Let's go back to our replit that we were working on. So I can import string itself. And then I can say return string dot ASCII. And let me take a look at that again. Underscore lowercase. And it looks like that will give me the individual letters. So let's see that. It has uppercase. And I wonder what happens if I just pass in the char there. So let's see what that looks like when I pass this. Okay, so it gives me an error because I'm trying to do the ASCII. So let's see what the error is saying. So the error is happening on line 8. Where is line 8? Okay, so the error is not actually related to the code here, but instead it's actually related to the fact that my conditional statements are not wrapped in a print statement. So now I can check my next one. Yeah, I still have a problem with line 8. It seems it's happening here. And it happens when it calls my function. And then it tells me that the problem is in line 6 in alphabet. So return string ASCII object is string object is not callable. But I am importing string. So let's see what's going on here. Maybe that just doesn't work inside of Replit. Or maybe I just need to grab the index. Let's see. Index. Let's try that. Okay, and then let's print this so that we could see what we're seeing. And if this doesn't work, then I may just go with someone else's. I did it dumb way, I made a list of letters. That's not a dumb way, that's definitely the right way. Okay, so it's giving me back the index. So it looks like once it gives me back the index, I could just do +1 to ensure that it matches what it's supposed to do. Okay, so now I got 1, 2, and 26, but they're all giving me false. So now I wonder why they're all giving me false. Well, it's because I'm not returning anything because I switched it out for a print instead of a return. And now I can clear my terminal and run this. And now I got true for all of them. Rick, it says that you use ORD. Do you want to walk me through doing that? That's
Can you hear
definitely.
me?
Oh, go ahead.
Okay. So what I did was, let me get on. So alphabet code character. I define a letter position. So let me see if I can get these side by side. I'm left my other monitor at work,
Oh, no problem at
so
all.
bear with me.
What did you do, Andrew? Did you make the list as well? That's the way I would have solved it. I would have made a list if I didn't know about string.
Yes. Yep. I made a list, and
Nice.
then I simply said return list dot index parentheses character.
Awesome. Let's see. I think I saw ord being mentioned down here as well. So is it around what you? Oh, I just saw it. I see it now. Ord letter minus ord a. Okay, so let's check out what ord is doing. All right, so let's go ahead and print ord and then send a char there. Let's see what this is doing when I run it this way. Well, you see, now it's giving me the actual value of the numerical value that the computer is interpreting this character as. So that's great. But just like it says there, we need to account for a. So now we want to do minus ord a, and this should bring us balance. Think about it as if we have A through Z, but I went too far to the right. So now I need to subtract the entire alphabet to get a closer answer of what I'm trying to do here. Okay, and now we get 0, 1, and 25. So now I can just add 1. And that is how you could solve this doing ORD. Okay. And then, of course, there's the other way where we make a list. But instead of a list, we could also do a string. So let's do alph, and let's make that equal to ABC. Okay, so now if we do it this way, I can also just return alph dot index of char plus 1. And that would also give me back, should have given me back once, but it seems that the sum string was not found. Oh, and that's because all of these are upper. So let me turn this into lower. Okay. And now it gives me truth. Awesome. And that is it for alphabet code. Does anybody have any questions on alphabet code? Yeah, I've never seen anybody solve it with OR. That was a great suggestion. Thanks a lot, Rick. All right. So now we got rectangle size. So write a method that takes in 2 number arguments, okay, representing the length and width of a rectangle and returns the perimeter of a rectangle with those dimensions. Okay, well, I don't know how to calculate the perimeter of a rectangle off the top of my head. So let's see, perimeter of a rectangle. Okay, so Google gives me the answer. It's 2 and then length plus width. Okay, so now I have length and width here. So how can I construct what perimeters, what Google is giving me as perimeter inside of this function? I'll have you guys walk me through this one.
You would just do perimeter equals and then equation, which is 2 parentheses length times width.
It's not times, it's plus.
I'm sorry, plus, yep,
Nice. So length plus width.
Yep.
Okay,
and
and
then return perimeter.
perfect. Return perimeter.
Yep.
Okay, great. So let's go ahead and run that through the shell. And there it is. We get back all of our truths. Awesome. Thanks, Andrew. Moving on to our next question. We got average velocity. Okay, let's see. So write a method that takes in an array of positions over time and the total change in the time and return the average velocity of the entire trip time will always be greater than 0. So average velocity is equal to change in positions divided by change in time. Okay, and we see the list of positions in here, and I want the change in position divided by time, basically. Change in position is last position minus first position. Okay, so let's see. So if I were to take 6 minus 0 and multiply that times and divide that by 10, well, then it would give me 0.6. And if I were to take 7 minus 3 and then multiply that times 4, or sorry, divide that by 4, well, that would give me 1. Okay, perfect. So how do I build this out? Someone walk me through this problem. Go ahead, Pia.
Sorry, my kid is here with me. But
Oh,
first thing I did was declare change in position. So I changed in position, right? Equals list of position index -1, because that says that's the last position.
okay.
And then subtract list of position index 0, because that's the first position. And then after that, the second one, I put the average velocity, which is given to us anyway. So average velocity equals change in position divided by time. And then return average velocity.
Nice. So let's try running this through the shell again. And we see we get nothing but trues. That was great, and great use of the -1. I don't think I taught that just yet, but this is fantastic. You use a -1 to grab the last member of a list instead of trying to calculate the length and figure out which one's the last element. Does anyone have any questions over Pia's solution? This is fantastic. Thank you, Pia. All right. So it looks like that's all we got for this one. Let's move over to our next problem. So our next problem is going to be gravity. Okay, so I'm an astronaut standing on the newly discovered planet X. Calculate how much your ship weighs in order to determine the fuel needed to blast off. Write a method that takes in the acceleration, so we got ACC, due to gravity on planet X, and the weight of your ship on Earth as integer/floats, and outputs the weight of your ship on planet X as integer/floats. So acceleration due to gravity on Earth is 9.8, and the weight is acceleration due to gravity mass. Okay. So it looks like I need to take the weight and multiply it times the acceleration given into the function divided by the acceleration that's defaulted on Earth to be able to calculate what my actual weight is. Okay. Can anybody walk me how to do this one?
Yeah, so I have my I have weight on planet X is equal to acceleration times weight divided by 9.8.
Acceleration times weight divided by 9.8.
And then return weight on planet X.
I could spell, I promise. All right, let's check this out. Perfect, and we see trues. So this is coming back correctly. This is great. It just, I know that this word problem was probably a little bit hard to navigate, because even as I was reading it, I was like, whoa, hold up. There's a lot of noise, and that's there for a purpose. It's to teach you how to grab the specific information that you need and how to implement it given a specific amount of inputs and outputs. So this is good practice. Awesome. Does anyone have any questions over the problem of gravity?
Yeah, I just had a question on that equation there, where you have acceleration times weight divided by
Recording in progress.
9.8.
Oh, infinite loop. Go ahead, Andrew.
So how do you make sure that you're not doing acceleration time, like the parentheses, because you could interpret that differently.
This?
The equation, acceleration times weight divided by 9.8. Like, are you dividing acceleration times weight by 9.8, or are you dividing weight by 9.8 and then multiplying that by acceleration?
I get what you're saying. Yeah, so I guess the way that we could interpret this, if I were to utilize something like TL draw, what we're actually looking at here would be something like weight times acceleration, and then we would have this fraction, right? And at the
Yeah.
bottom of that fraction, we would then have 9.8, which is what's given to us by Earth. So we're looking at multiplying weight times acceleration and then dividing it by 9.8. Does that answer your question?
Okay, yeah, it is. Yeah, thank you.
Of course, no problem. All right, moving on to the next problem. And now we have rectangle. So write a method that takes in two number arguments representing the length and width of a rectangle and returns the area of a rectangle with those dimensions. Ooh, is that base times width? Let's see. Oh, look at that, area of a rectangle. Computer's listening to me. So it's just width times length. All right. So width times length, that's all I really need to return. Anybody want to jump on this one?
So when I just did rectangle area equals width times length, then return rectangle area.
Okay, so you said rectangle area is equal to width times length and return rectangle area. All right, let's try it out. And we see our three truths. Perfect. Does anyone have any questions over this solution? Okay, awesome. That was great. Thank you so much. Let's move on. And now we got illegal word. All right, so write a function that takes in a sentence and an illegal word and returns a Boolean indicating whether or not the sentence contains the illegal word. Capitalization should not matter. Okay, so how could we do this? Let's break it down step by step, right? The first thing that it wants me to, that it tells me, so the first edge case that I want to handle is the fact that capitalization should not matter. So what is that telling me that I need to do to both sides of my function or both of my parameters?
Set them to uppercase or lowercase.
Okay, perfect. So let's go ahead and make them all lowercase. So sentence is equal to sentence dot lower. And let's make word equal to word dot lower. Okay, fantastic. So now I have that part done, where the capitalization will not matter because now they're both of my arguments are all lowercase. Okay, so now I go into finding it. How do I check if my word is in my sentence?
Just what you said.
Okay.
It's if word in sentence.
If word in sentence, perfect. Okay, and then, so if that's true, then I'll return true, which I'm assuming is the route we're going with. And then else I can return false. Okay, so we can do this. And if I run it, we're gonna see that it's gonna run properly. Right, we standardize both of our strings, and afterwards we could just check if the lowercase word is inside of the lowercase sentence. Instead of doing this if and else statement, we could also just return word in sentence, because this is going to give us a Boolean value of true or false. So now when I run this, it returns all trues as well. Awesome. Does anyone have any questions over the illegal word portion of today's exercises?
But don't you
Yeah.
want the first answer to be false?
Thanks, PF.
No,
Same.
so when this comes back false, then I'm basically asking, is false equal to false, which is true. So here in the terminal, I should see all three coming out to be true. Does that answer your question?
Yeah, I think it's because you're asking for a Boolean, right? But
Correct.
if you didn't do it the other way, if you just print it, it would be false, right?
Yeah, if I printed it here, that would give me false, yes.
Okay. Yep.
That threw me as well.
Okay, awesome. All right, let's move on to the next one. So our next one, we got some potato. Okay, you're the teacher of a class with 5 students. Ooh, student 0, 1, 2, 3, and 4. And you want to play a game of hot potato. Initially, you give the potato to student 2. After each turn, the student will give it to the student on their right. So the student 0 will give to student 1 will give to student 2, and so on. Okay. So student will give to student 0, write a method that takes in the number of turns and returns an integer representing the student that the potato lands on without using loops. Okay, so I'm not using a loop here, and I'm just trying to figure out where the potato is going to land without utilizing a loop. So we know that it's going to start at student 2, right? Is that where we initially give this to student 2? Okay, so we know it starts at student 2. And for example, if the turns are 0, then we get back student 2. What if the turn is 1, then it goes back to 3. So I guess the first thing that we could do is say return student or turns plus 2. All right, and then I could just comment out the last edge case so that I can run this. So Python 3 main. Okay, so I get back all of my truths, but now there's only a total of 5 students. All right, so there's a total of 5 students, and I add 7 to 2. Well, now I get 9. So that's not what I want here, and we see that it's supposed to return 4. So maybe I should check if I should do some type of conditional, right? So let's say if turns, and let's just say, let's call this end state. And then we'll say if end state is less than 5, then I want to return end state. And else I would like to return end state minus 5, because I want to subtract the total number of students, because we're basically restarting our loop. Okay, well, if I run this now, I should get all truths, and there we go. We got all truths. Does everybody understand this potato problem and how we went about solving it? Okay, awesome. Anyone got any questions or suggestions?
I did it a very different way.
Okay, let's hear it out.
So I started with, since there's 5 students, I started with if turns modulus 5 is equal to 0. So that would mean that it got passed around 5 times back to student 2. So I did return 2. And then I did a few elif statements where it still turns modulus 5. And if it's equal to 1, it'd be student 3. And then if the remainder was 2, it'd end on student 4. And then a remainder of 3 would end on student 0.
Is that correct? Or is there another remainder?
So I did all of them basically. So if there's a remainder of 0, student 2, remainder of 1, student 3, remainder of 2 is 4, remainder of 3 is 0, and then remainder of 4 is student 1.
So we could just do else return 1. Okay, this is actually a way more efficient answer. And if I were to run this, it would definitely work. Right? And this is why I say it's more efficient. So in my answer works when I'm considering a small amount of turns, right? So now let's say that I'm running a problem and my problem happens to have 27 turns. Okay, if I run this, the answer that, sorry, who was it that gave me this? Was this Patrick?
Albert.
Albert, yeah, the answer that Albert just gave me will return true. But the answer that I created will actually return false. Right, and let me just print this out so that we can all see it. So print end state minus 5. So we see that my answer actually only gives me back 24. Because after I pass in 20, and that's weird that it would give me back 24, because technically it should have gave me back 22. Oh, no, because I added 2. That's right. It should have gave me back 24. So it gives me back 24. But I was fully expecting it. It didn't take into consideration the fact that it has to restart over and over again, regardless of how many turns there is, right? So if I turn this into 57, well, my answer is even going to go further away. Whereas in the answer that Albert provided for us, that's much cleaner, much more efficient, and it actually takes into consideration a higher number of turns. That's great, Albert. Thank you so much. All right, moving on here. Oh, well, actually, before I move on, does anyone have any questions over the answer that Albert came up with? All right.
Mine was just way shorter. I just had return and in parentheses 2 plus turns. And then outside of that, mod 5, the modulo 5, because there are 5 students. That's all I had. I mean, it worked.
No, I mean, yeah, so this is definitely definitely good as well, right? Because if we take 2 and I add it there, well, it gives me 59, and it just compiles all of the if statements that we had received before. Now it's just giving me once I add it, return the modulo 5, whatever's remainder of it, right? And even if I did something where it's an even number, so something like 50, it would still just, oh, well, actually, if I do 50, oh, I'm sorry, that should give me 2. So let me run that, and it still returns true, because I have 2 plus the number of turns modulo 5. This is great. Talk about efficiency. I like it. Awesome. All right. Moving on to the next problem. We got drinks. So every weekday, every weekday you drink caffeine to get ready for the morning. Monday, which is represented by M, you need 800 milligrams to wake up from the weekend. Tuesday, you only need 600 milligrams. Wednesday and Thursday, you only need 400 milligrams. But on Fridays, you drink 900 milligrams. Because you know you'll be staying up late and going out with friends, you prefer buying small energy drinks that contain 150 milligrams of caffeine each. Write a method that takes in the day as a string and returns the minimum amount of caffeine drinks you'll need to buy for each day. Okay. You drink 900 because okay. Awesome. So this whole thing that we just described here, there's a couple of ways to go about fixing this, but we could consider utilizing a specific data structure to fix this problem, or we could just use control flow to try to fix this problem. So I want to hear what everyone's answer is to that question. How many of you use control flow to handle all these edge cases, and who used a specific type of dictionary? Oh, I just gave you guys the answer, but who used a specific type of data structure to be able to solve this problem? A dictionary, awesome. And how did you use that, Crystal?
I made a dictionary called caffeine underscore consumption. And I had the keys be the letters for the days of the week. So M, T, W, R, and F, and then the values for them, the corresponding amounts of caffeine. So M is 800.
Okay, give me
You just
I gotta catch
you
up. Caffeine consumption.
Yeah.
Uh,
Yeah, I agree though. That does sound like a deadly amount of caffeine. That's a lot of caffeine.
Okay, so M is what?
800. And then T was 600. And then W is 400. R is 400 as well. Then F is 900.
Monday, Tuesday, Wednesday. Was there supposed to be a T as well, or is it or oh
No,
yeah,
so R is Thursday. So F for Friday.
F, and this one is 900, right?
Yes.
All right.
Do the
Okay.
spaces matter after the keys or no?
No, they really don't. That's
Okay.
just more formatting for me than anything.
Okay, cool. I also for this I imported math to get the rounding. Because I use math seal for math sealing.
Nice.
There's maybe something built in that works for it, but this is what I found. So, but for drinks needed, I just did drinks needed equal math.ceil and then put caffeine underscore consumption brackets char divided by 150.
Brackets char divided by 150, you said?
Uh-huh.
All right, perfect.
And then I return drinks needed.
And let me print that so we can view it as well.
No, you might have to import math. I
did.
Oh, up at top. I see it. I was looking above define. My bad.
No, you're okay.
Yeah, return heart attack.
Nice, perfect. So we have our 6 and our 3, and this is great. Yeah, I wonder what would happen if I just used the round method. Let's see what that does if I just utilize round. I don't pass
Yeah.
any elements in there.
That failed for me because if it's less than something .5, it rounds it down.
Right,
You'd still need more of a drink.
perfect. Yep. So we definitely need the map.seal. And there you go. Easy peasy. Does anyone have any questions? Okay, awesome. Yeah, I would say this is definitely the best way of doing it. Utilizing control flow would have been a lot of if and if else statements all the way down until getting to the else. So this is probably the best way of solving it. This is awesome. Thank you so much. And then was this Crystal? Yeah, it was. Thank you. Really appreciate you sharing that. Let's move on. And now we got our last but not least. Can I go to the bar problem? Okay, so write a function that takes in a number argument and returns a Boolean if the person is of age to enter a bar or not. Okay, so I just want to return if a person is 21 years or older. So how can I do that? Let's see, who hasn't gone so far? Alex, I don't think I've heard from you yet. You want to hop on this one?
I'm sorry, I didn't get to get through very many of these, so I'm playing catch up.
Yeah, no problem at all. All right, let's see. Ty or Laura, do you guys want this one?
Sure, so I think we can return true if num is greater than or equal to 21, else false.
Nice. So let's see what this looks like here. And I can just say Python 3 main. Okay, so this works well. Did I cover this or did you just already know this?
Ternaries, I just knew it.
Okay, awesome. So just to clarify this is the same thing as saying the if num is greater than or equals to 21, then return true, else return false. But this is just a ternary variable, which is where you write it in one line. How could I make this shorter? Can anybody hop on this one and tell me how I can just refactor this to make it a little bit more efficient? Yeah, so the num greater than or equals to 21 is already returning a Boolean variable. So I could just make the operand there and run that into my code. And that's it. Those are all the problems that we had yesterday. That's awesome. Anybody already hop into day 4? I'm sure a bunch of people hopped into day 4 already. Okay. Anybody have any questions over any of the last 2 days assignments before we take off for a break? All right, perfect. Let's go ahead and take a 10-minute break and come back at 7:53, or let's just make it 7:55. All right, see everybody in a bit. All right, welcome back everybody to session 3 of Intro to Coding Live in Python. So let's move into some built-in methods. We're going to be starting off with the string built-in methods. So here we got a couple of common ones. Actually, this is just covering all of the built-in methods, and this is just covering the fact that each individual data type has methods that you can apply to them. We've already messed around with round in a couple of our math problems. We haven't touched append, but that is a built-in method that belongs to lists. And we haven't, actually today, we utilized lower or upper to be able to solve some of our problems from last night. So as you guys know, all of these methods you can easily find online as well. You can look up any type of string methods in Python. I don't think anybody would ever assume for you guys to memorize every single one of these methods and how to apply them. So just know that there are resources out there. All right, so we got all of these common built-in methods, and here we provided some resources. Whenever you guys go through the slideshow, I believe I sent out a link to everybody so that you guys all have access to the slideshow. You can just click on the links, check out what they have. So for example, if I click on lists, we see this list opens up and it tells me all of the individual things or methods that Python lists already hold inside of it. Okay, so moving on through built-in methods. So a method is basically a function. As we specified already, a method is a function of a specific data type. So a data type is considered a class, and any function belonging to a class is called a method. So now we know that strings have methods, and we know each individual data type has a method, and this is just iterating over it all over again. So the action performed may either mutate the data in place without returning a new value, or it cannot mutate the existing data. So this part right here is actually super important. Another way to talk about it is called constructive or destructive. Destructive meaning that it will destroy the original value and then create a new one. And then constructive means that it will create a new value, but unless you store it somewhere, it's not going to stay anywhere. It's just going to store it temporarily and then it's going to go away. And we'll go over some examples of that as we start going through the methods. All right, so here we got some methods. We got swap case, title, and find. So example of hello.swapcase, and we see hello switching to where all of the lowercase letters now go to uppercase. So let's actually spend some time going through some string methods. So let me, boom, here it is. So here's a ridiculous amount of string methods, but the most common ones I will show here. So let's move over to our editor here. And real quick, we're going to go ahead and, interesting, I don't see main. Okay, so it looks like, oh, this is the wrong one, I believe so. Let me back up here. And let me go into the correct lesson. That is a considerable amount of replets that we have just cloned. So let me look up intro. Okay, intro to coding live, lessons. Okay, it seems like this is gonna be the file that I'm gonna use. So I'm just gonna get rid of challenges here. Yeah, and then I'm just gonna create a new Python file and I'm gonna call it lesson. And I'm gonna say 3. Oh, that was the wrong command. So let's move that file or overwrite that file. All right, so now we have lesson 3.py. We can open it up. All of these other lessons are no longer existent. All right, so in lesson 3.py, we can start going with our actual string methods. So let's go into them. Let's say my string, all right, how original. And let's just start with hello world. All right, so now let's print. And here's the difference, right? So if I say my string dot upper, I'll try to, and then I go to print my string. Oh, that's not it. Okay, we see that my string is still in the same lowercase / uppercase letter format that we have. So that means that this was able to construct a new value, but it never assigned anything, right? And it didn't go anywhere. It only lives in this line of code. If I print this line of code here of my string, well, now we see that my string.upper is all uppercase letters. But then when I go to print my string again on line 3, it still holds its original value. It was never overwritten. So if I wanted to overwrite it, I would have to say something like this. I would have to say my string is equal to my string.upper, and then I could print my string, so that I can store it in the same exact value. Okay, a different one would be lower. When I run lower, we can see that it turns all of the words into lowercase letters. And then my favorite one, which is swap case. And the reason why it's my favorite one is because when I was new to programming, I used to always get a problem that would tell me to change the capitalization of all the letters inside of a string. And in JavaScript, there's not a swap case function, and I used to use nothing but JavaScript. And because of that, I would always take forever to answer that question. I would have to build the loop, have a conditional where it would recognize if it's an uppercase letter. And if it was an uppercase letter, I needed to store it into some sort of array or string. And then I needed to make it a lowercase letter. Afterwards, join everything and return that. Well, now Swapcase does everything that I just said for me under the hood. And when I run my code, it just switches all of the cases. Any letter that was lowercase is now uppercase, and any letter that was uppercase is now lowercase. Okay, let's take a look at some other methods here. So now we have the alphabet, the index, sorry. So let's go ahead and say that I needed to grab the index of the letter O. It gives me the index of 4. And as we see here, 1, 2, 3, 4 gives me the index of 4, but it doesn't give me the next one. So I wonder if there's a method that will give me all of the indexes where it exists. So let's see if we can find it. Okay, so we have this one instead, where it can give me the last position where it finds it. Same thing if it returns the last position. Okay, we have a starts with variable. I know it's somewhere. Let's see. Okay, well, we can try the find and see what that does. All right, let's go ahead and move over and let's say find. Again, it still returns the first index. Now, what's the difference between find and just calling index? Let's say I pass x. X isn't anywhere in my string, so it returns a -1, but doesn't break my program. Now, if instead of find, I try to use index, and I'm trying to tell it to find the index of 4, it's going to break my program because it's going to tell me, hey, look, the x does not exist inside of this string. So if you're trying to find the index of something and you don't want your program to break if it's not found, then you want to utilize find instead of the function of index. Let's see what else we got here. We got count, which gives me the number of times that a specific string is inside there. So let's say I run count of x. Well, this should also give me a -1. What actually gives me a 0 because it's just not in there at all. And let's say I run the letter O. This one should return 2, but it's important to note that these functions are all case sensitive. So if I were to pass something like the uppercase L, it returns 2, even though I have a lowercase l in the middle of the word world. What other functions do we have here? Let's see, we went over find, index. Oh, these are good ones. So we have is alnum, is alpha, is digit, is numeric. All right, so all of these functions are going to so this one is alphabet or num is going to return true if the character in the string is alpha or numeric, meaning that it could either be a letter or be a number. So let's check that one out. Is num, and let's pass L. We should see true there. Oh, actually, it's going to evaluate the current string that I'm calling it on. So for this one, it gives me false because it's not a letter, nor is it a specific number. So for example, if I do this, it gives me true because it is numeric. And if I run A, it should also give me true because it is a letter. Now, if I try to switch it and do something like a special symbol, and then I run it, it gives me back false. All right. And it also has its own individuals. So let's say we do is alpha, and I make this into a number 5. We know this is going to return false because this is not a numeric number. But I can also say is numeric. And when I run this, it returns true because it can be casted into an integer. All right. Let's see what else we can find here. We went over is numeric. I can check if something is all lowercase or is all uppercase by using is lower or is upper. I can even check if it has a title. And I don't think I demonstrated title. So let's bring that back. Okay, so now we have my string and I want to utilize title. Well, when I run this, it's just going to simply capitalize the first letter of every word separated by an empty space, right? And only separated by an empty space. If it's not separated, it just makes everything lowercase after that first letter. All right. And I think that's it for strings. Let's go ahead and move on to our next data type here. Okay, so our next one is going to be numbers. So we have abs, round, and pow. So let's go over that. Number is equal to, I don't know, let's say negative 15. Right? Well, now if I want to print the absolute value of number, when I run this, I just get 15, right? And the reason why I only get 15 is because I'm grabbing the absolute value. And let's say I do pow. Well, pow actually takes in a couple of arguments. It takes in the first one being the base and the second one being the exponent. So I can say something like number, comma 3. Run that, and it gives me whatever number it is, so times of 3. Right, I could give it 4, and it should account for positive numbers. So now we see that it's still a positive number. And we know that this is also the equivalent of saying number times times. Sorry about that. Left a little extra parentheses. Yeah, so we see that pow is working there. But our integers altogether really don't have many built-in functions other than the ones already provided by our math values. So let's go into list, and here's where things get a little interesting. So list has all of these values which can append, remove, pop, etc., etc. Let's actually, let me escape this, and I'm gonna actually grab this information and bring it over so that we can start demonstrating a little bit. Okay, so dot append, let's say foods, and this is equal to hot dogs, and then we have burgers, and then we have steak. Oh, what did I get myself into? I hope that's the right steak. Otherwise, it's going to be really embarrassing because this is going to end up on YouTube. Let's say chicken salad. And then what else? Can't really think of many foods here. Anybody got any ideas?
Fries.
Nice. Rice. And that would be good for now. Okay, so now I have this list. And let's say I wanted to add something into this list. Well, I can't just do something like foods plus, and then say pizza, right? Because this will return an error. And if I try running my file, we can see that it's going to return an error because I'm trying to add a string into a list. Let's say I turn this into a list. I wonder if I could add them together. Well, it turns out I can. So let's go ahead and print foods here. So although it's letting me add it, it's not really saving anywhere. And I also I wonder what would happen if I print it up here. Well, now when I run this, we see that pizza's at the end. But again, if I print foods afterwards, it's no longer inside of my list. Right? It's only there temporarily. So there's this actual function that we can use called .appends to be able to add individual elements in there. So I can say .append, and then now I can place pizza. And I'm trying to print this function out for some reason, which I apologize. So let's say I take off that. And now when I run it, we can see that this is destructive because it's destroying the original information that was inside of foods and then giving it a new value. And that new value now includes pizza. And now anywhere after this line that I reference to foods, it will always have pizza inside of it. Okay, let's go into remove. Or actually, let's go into pop. Let's say I wanted to pop the steak. So if this is how I append something, how could I pop the steak? Anybody want to jump on that one?
This is just foods.pop steak.
Yeah, so let's do foods.pop. And let's pass in steak. And let's continue printing foods. Okay, so it looks like it messed up. And the reason why I messed up is because I'm trying to pass in steak itself, but it's looking for an index, right? So string object cannot be interpreted as an integer. So it's looking for an index. So now let's say I wanted to use this. How could I get the index of this information?
Would you not just put 2?
So I could put 2 if I knew it, right? Because we do know it. And I could utilize 2. But let's say I didn't have access to this part of my code. It was somewhere else and I can't see it, but I know it's coming in. How could I find the index of steak inside of foods so that I can pass it to foods.pop?
You could do foods.index steak and set that to a variable. So I don't know what you want to call the variable, food to remove or something like that.
Yeah, I could definitely
or remove.
Yeah, I could definitely set it to a variable. So let's say index of steak. And then I can pass it here. Index of steak. And now when I run it, it runs correctly, and it's actually able to get rid of steak. Now, the cool thing about pop, instead of utilizing remove, is that when I use pop, I can actually save the value that I'm getting rid of to the steak. So let's say value from pop. Let's make that equal to something. And let's say I just print foods. Oh, that's the wrong thing. And let's say I also print value from pop. When I run this, we can see that state still exists inside of the variable of value from pop. But the only thing that exists inside of it is stake, which is the item that removed from there. Now, if I try to use something like remove here, and then I run it, well, now remove is actually not looking for an index. Remove is looking for a value. So let's get rid of that line. And let's say stake here. And now we see that stake is not inside of our original list anymore. But when I try to print the value that was removed, it just gives me none because this function doesn't return anything, but pop did. So pop returns the value that are removed so that we can save it to a specific variable while remove doesn't. All right. Let's see what else we got here. Okay, so we got an insert. So insert can insert a specific element into a list. So after removing stake, let's say I want to do the index method, right? Well, now where stake used to be located, I want to insert apple. And if I read this, it says insert an element in a list in a specific index item. Okay, well, let's check out what it will do. So I can print foods there. And let's say I can say foods dot insert, and it tells me that it takes in two parameters, one being index and the other one being the object. Okay, so knowing that it's looking for index and object, how could I insert apple where stake used to be located? Okay, so where is the index of stake? Where is it that stake used to be located?
Index 2.
Right, index 2. And we save that here, right?
But if
So-
it's removed, if it's still removed, then isn't chicken salad index 2 now?
Yeah, so let's right, so now salad would be index 2, but when I run this insert function, I'm basically telling it to place my whatever it is that I'm telling it to do on that spot where steak used to be. So salad will move to the right and replace everything. Does that make sense?
Yeah. So is it apple comma 2 or 2 comma apple?
Yeah, so it would be 2 comma.
Is apple what we said? I forget.
Yeah. And I think the only thing that we would want to do is instead of using 2, because if we're working assuming that we wouldn't have access to this list, we would instead use index of stake here. So index of stake, comma 2. Now I can clear and run my language. Okay, it's telling me remove's not working correctly. And that's because I'm passing index of stake now. Well, I can do pop. Okay, and there you go. So now we see hot dogs, burgers, rice. Oh, I forgot to print it. Huh. I was freaking out. Print foods. Okay, so we'll get to see it after the pop, and then we'll see it again after the insert. So see hot dogs, burgers, chicken salad, rice, and pizza, right? So that's after I removed the steak. And here's after I insert apple where steak used to be located. All right, great. Does anyone have any questions over these well, we went over like 4 methods so far. Does anybody have any questions there? I know it's a lot of information. I'm trying to make sure that I'm going over it in a pretty good amount of detail, but I don't want to make this class too dry at the same time. All right, so we went over append, we've gone over pop, remove, insert, index. The only ones left, so we already know what count does. It's going to do the same exact thing that it does with string. So let's say now I want to print the amount of times that foods has hot dogs. So let's say count, and let's run hot dogs. And actually, let me comment these two print statements out here. Okay, so it tells me it only has it one time. Let's say I wanted to add it another time. Okay, it still returns one. I wonder why. Oh, I forgot to place a comma there. And there you go. Now it returns two. Okay, so there goes count. And then we have sort. And sort would work better if we're utilizing something like numbers. But let's see if we can depict it, what it would look like here. Okay, it takes no positional arguments. That's right, it does not. Okay, so now it's saying none because again, it's destructive. It's not returning a value. I would have to print it here. Okay, and we see that it just organizes it in alphabetical order. And lastly, we have our join. So here we can do, so now join, I'm sure everyone here is more familiar with JavaScript. In JavaScript, we used to do something like array dot join, and then you would pass in the parameters that you wanted to join. Well, you could do the same thing here. I can do, but it's backwards. So I do the parameter in which I wanted to join, and then I can pass join, pass this in there. Okay, and now we see Apple Foods, the chicken salad has the space where it's supposed to be. Okay, so this looks good somewhat, but it's not necessarily what I want. Maybe I want a comma in between every item. Okay, now I have a comma in between every item, but it's still pretty tight. I don't like that. So I'm just gonna also include an extra space. And now when I run it, all of this is one single string. Okay, and those seem to be all of the different types of methods that we have for lists. Does anyone have any questions for the methods that include lists? All right, if you don't have a question for me, then I have a problem for all of you. So we have this list, and what I want to do is any item, I want to iterate through this list and find every time that the food. Okay, so let's do it this way. If food is hot dog, I want you guys to remove / replace hot dog with a list of bun, and I'll just say weenie. Okay, so given this problem, how is it that we can fix this? How can I create not necessarily a function, but how could I finish this program that will do this to the list of foods? All right, let's take it step by step. What's the first thing that we need to do in order to be able to evaluate each individual item inside of the foods list?
Would we need to count how many times it appears?
Yeah, we could do that. Let's say I want to do count of hot dog appearances. And let's make that equal to, how do I grab the count of how many times it's inside of this list, Alex?
I'm not sure.
Okay, yeah, definitely. So we have this dot count method, right? Okay, so we see dot count. Steven's passing it on the chat. How could I use it, Steven? Okay, so then I got foods dot count. And then what would be the parameter that I pass into count?
And hot dogs.
Nice. So now I can grab hot dogs. Okay, so let's make sure that's running correctly. Okay, so now we have the count, which is equal to 2. So now I know there's 2 instances in here where hot dog is located. Now what do I need to do?
Find the index of those occurrences.
Okay, great. So let's say it looks like we're gonna have to start a while loop, right? Because we want a behavior to happen while something. So let's say while count of hot dog appearances is greater than 0. Okay, so you said find the indexes. So let's do that. Index of hot dog. Because remember, this is only going to grab the first index, right?
Mhm.
So we need foods, and then what built-in method would I use here?
Index.
Nice. Okay, so then I grab index, and my parameter would be
Hot dogs.
okay. Great. So I grab the index. Now I have the index of the hot dog. And now I need to utilize either pop or remove to get rid of the hot dog from inside the list. And then I need to utilize insert to insert the list of Bun and Winnie into the list of foods. So how do I do that now? So we already got the index. Can somebody walk me over how I would pop the individual index from the foods list?
You would do foods dot pop, and then in there would be index underscore of hot dog or hot dogs, whatever it was. Yeah.
Index underscore of hot dog. Great. So that's going to go ahead and remove the hot dog from my actual foods list. Okay. And now I want to insert the list of Bun and Weenie into my foods list. So how could I do that?
Were you trying to replace one of the hot dogs specifically? Like, do we have to place it in where the first one or the last one was? Or is there a way to know which one was removed?
Yeah, we want to make sure that we place it inside of the same one, the same corresponding one. But we were able to grab the index of the one that we removed. So we know where the index is located here. So we know where to in this, since we have the index of hot dog, we can still utilize the index of hot dog in our insert method to be able to place the list of Bun and Weenie.
Do insert.
Right, so we got foods dot insert. And then what needs the index is the first argument. So what index would I pass in there?
Index of hot dog.
Nice. Index of hot dog. And then what would I replace it with?
The bun and the weenie.
The list of the bun and the weenie.
Nice. Bun and weenie. Okay, so now this loop is going to continue going because I'm not changing the count of hot dog appearances. So maybe I want to change that. How could I change that? Right, because if I don't make count of hot dog appearances go down, it's going to continue doing this behavior until it causes an error. So I want to make sure that I decrement as I do this behavior. So how could I decrement the count of hot dog appearances on line 25?
Count of hot dog minus equals 1.
Yeah, so we go count of hot dog minus equals 1. Perfect. And then at the end of this, let's go ahead and print foods so that we can see what our cumulative work looks like. Okay, so the first hot dogs was replaced by bun and weenie, and next to rice, which is the last hot dog, we see that it's replaced by bun and weenie. That's awesome. That is a good amount of practice with list manipulation, and it solidifies all of our work. Let's see. We have, why can we not just use food stop replace hot dogs, buns, and weenie? Well, let's try it out. Let's say foods dot replace. And after I use foods dot replace, well, now I'm going to pass hot dog. And then you said to pass in bun and weenie. Clear this out. We run it. Well, it's going to tell me that the list doesn't have a replace method. So if it doesn't have a replace method, can you think of any way that I can make this work, Andrew? I know that the replace method belongs to string types. So how could I turn this list into a string?
You would just, you could do food, string foods. Just make a new variable, string underscore foods.
Okay, food string is equal to
Equals string or str parentheses foods.
all
Or then
right.
you can do food string equals string foods dot replace.
Dot replace. And let's see what this looks like first before we continue moving forward. So let's look at food string. When I run this, I forgot to pass in foods. Nope, I named it correctly. What's the name error happening from? Now it's happening on line 21, food string.
Yeah, on line 21, you have it called food, but it's referenced as foods. Food is not defined. Everything else is foods.
Yeah, but everything is foods, right? I didn't miss it somewhere. Okay, it was just being weird, I guess. All right. So it looks like even though I tried casting it into a string, it didn't cast it into a string. Let's try to check the type. Okay, so it did cast it into a string, but that string is also including the brackets. Yeah, so that string is also including these square brackets. Okay, I guess it's fine for now. And now we have food string, and let's keep going. You said that you wanted to use replace. Okay, well, replace takes in a couple of arguments. Let's see if it tells me. So it looks like replace takes in the old argument and the new argument. So how could I finish this out?
You put hot dogs in parentheses,
All right.
and then comma, bun weenie.
Okay. And let's do one. Weenie. Right, and let's just print food string. Okay, and we see that it was actually able to replace it, right? We got bun and weenie, et cetera, et cetera. But now we have these quotation marks right outside our square bracket. So I wonder what happens if I do it this way. Well, that's failing. So maybe that's okay if we have the quotation marks. Maybe that's just its way of interpolating string. I wonder what happens if we turn it back into a list. What will it do? Okay, well now when I turn it back into a list, it seems to break up everything, and that's definitely not what we wanted. There may be an edge case where we can utilize this, but I think for the time being, we might want to do a little bit more of the list manipulation orientation.
Would join have worked instead of list?
Join?
Yeah, so that the last part isn't read as a list.
Well, it's already, it is joined, so this is all just one string. I know it looks like a list right now because it has the square brackets, but it's actually being interpreted as a string. If I check the type and I print it, we see that it gives me class string. But I may be able to do split instead. So let's check that. Dot split. And let's say I wanted to split every time there's an open space. Or actually, I think it was this. Okay, so it did split it, but now we have a string inside of a string inside of our list. And our list is a string holding a list of a string with a list. Yeah, so that's the reason why we sometimes replace just isn't the right answer. I'm sure we could definitely spend some extra time trying to go into the deeper weeds of if and else statements on making this happen. But I think the best way of doing it would be to do the list manipulation like we altered earlier with all of the built-in methods. And the way we did it actually utilized all of the built-in methods, but please note that we could just do foods, index, grab the hot dogs, and let me actually do it this way. So let's do for index value in enumerate. And then we want to do it to foods. Well, now I can say if value is equal to hot dogs, then I want foods at IDX to be equal to bun and weenie. Oh, probably should print that, right? So let's print foods. I don't know if I break it. Oh, there you go. And now when I print foods, it gives us the same exact desire that we were trying to accomplish. But the way we did it utilized all of the methods, which is perfect. That's what we wanted. Doing it this way is just one of the examples of why we could utilize a for loop. All right. And with that said, let's move on into our next set of built-in methods. Oh, and actually that's weird. That shouldn't be it. All right. It looks like that's it for today. So let's talk about some problem solving real quick before we go out for a break. So in problem solving, how to think like a programmer, understand what the problem is, asking you to do, how many inputs are required, and what data types, what's the expected output, and what data type should it be? Give an example of the inputs and expected output. Do I need any other variables? Break down the problem into a smaller problem. So this whole thing is just talking about how we can actually think about doing something, right? And then one of the biggest things here, we have this Google. It's telling you, hey, make sure you Google something. You know, in today's technology, we have great AI tools as well that can help us learn new skills. But just make sure you're utilizing those tools to assist your learning, not to give you answers, right? Let's see what we can do here. Let's grab one of our Python challenges. And let's see. FizzBuzz, last four of social, high score. Which one can we do together? Let's do last four of our social, and let's break down the steps that were inside of that slide. Okay, so last four of a social. So write a function that takes in a number that represents a social security number and returns the last four digits as a string of the social security number. Look into using the following built-in methods: string, split, slicing, and join. And I didn't go over slicing, so let me cover, well, this is perfect so that I can cover it here. Okay, we have this method here. They're all numbers, but notice that we're returning string. So let's break that up real quick. And, oh, sorry, let me make this full screen. Oh, did I not fork this yet? I did not fork it. So let me fork that real quick. Okay. So now we have that. Let me close this sidebar so we have some more space and we could actually visualize our shell. All right, so let's bring up the slide. So understand that the problem is asking me to do. How many inputs are required? So I know that I'm going to need a total of one input. Oh, okay. So I'm going to have one input, which will be the number that's provided. And this one input will be an integer type. All right. Now the next part is asking me, what's the expected output? Well, the expected output is the last four. And it should be a string type. Now give examples of the inputs and expected outputs. Well, we have those examples here, right? So we could take those into consideration. And let's actually just, yeah, we have them there. So we could take those into consideration to understand what type of integers there are. We can identify some commonalities, like how many of them there is. Maybe we can figure out how that works, as long as maybe if there's a commonality of how long each individual integer is, we can just come up with a solution that would solve the specific amount of digits. And then do I need any other variables? I don't think we would need any other variables in this case. Maybe one where we cast it into a string, right? Because we would have to turn this number into a string. So a variable where int is now string. Okay, what else do we need? So I need to break down the problem into smaller chunks, and I need to run my code often and debug it. Okay, so break down the problem into smaller chunks. The first one is going to be turning it into a string. How could I do that here?
So you can put social underscore string equals string social inside.
All right, so now we pass social, and that should turn it into a string. And now I maybe want to check the type here to ensure that it worked. And it looks like I put social because I can't spell. And now we can do social string. Maybe I want to comment these 2 lines of code out. And now I can run the Python and main. Okay, so we see that it's actually giving me back a string type. Okay, great. So now that it's giving me back a string type, I just want to grab the last 4 digits. So how can I do that? Well, I haven't covered it. So let's go over a couple of different ways that we can do it if we don't have slicing. Right, so pretending we don't have slicing, how could I grab the last 4 digits? Utilizing everything that we learned yesterday, like a for loop or a while loop, how could I iterate through the social, which is now a string, so I can actually iterate through it and grab only the last 4 digits?
So you could set up a for loop.
Okay. Awesome. What type of for loop?
So I would say like for indexing, let's say range, what do we want? The last 4 is 9 digits, so 5.
You say that again, Ty?
Oh, I said like, let me see, 0, 1, 2, 3, 4. So I would want, in range 4, 4,9. Are you hearing me?
Yes, I could hear you now. 4,9.
Okay.
Okay. Yeah. So this could definitely work, right? Where we're going down the right path, but we want to grab the range.
So actually, before I do that, I would set up an empty string.
Okay.
So basically, my plan is I would just like set up a for loop, yeah, empty string, and then for those indexes or index, sorry, I would just say for index and range, sorry, answer plus equals social string bracket index or bracket IDX.
So string bracket IDX. Okay.
And then I would return answer.
Nice. Let's see what this does. So it starts at 4. Okay. Let's clear it. And I'm actually going to print the answer so we can visualize it as well. Okay, so we got 00156. Okay, so it looks like we went a little too far. So maybe just changing that for a 5 will do the trick. Okay, and it does the trick. So that's awesome. That's fantastic. Really like the answer. The only thing that I would suggest changing would be this 5 and 9, right? Because this is assuming that we know the specific answer. And if we wanted to take into consideration every single input, well, instead what we can do is do the len of social string. And we know we only want 4, so we could start at the len of social string minus 4. And this may be a little harder to see. There you go. So now we see we get 0, 1, 5, 6, and we get back true. And if I were to uncomment the other two sections, when I run it, we also get back true. Right, and this is a perfectly good example of breaking down the problem into smaller chunks so that we can assess each one of the steps. Great job, Ty. Really appreciate your help. Does anyone have any questions over how we solve this algorithm, and more importantly, over how we broke down the problem so that we can actually turn it into digestible pieces, right? I think that the term I always hear is bite-sized pieces. You want to just start at the smallest problem and then start putting each individual small answer together to make your big answer work. Yeah, does anyone have any questions on this? Okay, let me show you guys the string method, the slicing method. So string slicing actually works where I can just say print social string, and I can spell. So I can say print social string, and then I could give it the square brackets, right? And in this square brackets, instead of giving it an index value, I can pass in a colon. And then by doing that, Python knows that I'm trying to slice, meaning that I'm trying to grab an individual set, whether that be from beginning to end or start to beginning. And the two arguments, the first one is where it should start slicing, and the second one is where it should stop slicing. Well, I know that I should just start slicing from -4, and then I'm going to leave this second argument empty because I should start from -4 and go all the way until the very end. So I can then clear. And when I run this, we see 0, 1, 5, 6, 8, 3, 5, 7, and 0, 7, 6, 9. So I can now return this statement and still get the same result. And that is slicing for string. All right. Is there any questions over anything that we went over today before we go out for a break? Okay, perfect. Let's take a 10-minute break and let's. Oh, hey, Francisco, I have the access. It will be on YouTube, but I will send you a YouTube link through Slack. Thank you for letting me know, Andrew. All right. So again, let's take a 10-minute break and let's come back at 8:05. See everybody in a bit.